Hello, everyone.
Good evening from Cambodia.
Hi. Hi, how are you in Cambodia, ITC? Kinath,
Yeah, we are
Professor.
doing fine. Yeah, thank you very much. Thank
Yeah,
you
should be.
for informing us to join this talk tonight. Tonight from Cambodia side.
Yeah. I mean, I really appreciate to join that such a late time, but very happy to have you. So,
Yeah.
okay, now everyone. So it's time. So let us start today's webinar. My name is Gennai Kamata. I'm currently working for UNEP, Global Alliance for Buildings and Constructions, and also the Cool Coalitions, where I'm coordinating the passive cooling portfolio. And I also coordinating this passive cooling working group. So for this working group, we discuss uh, so we basically discussed the passive cooling strategies that can reduce the dependence on active cooling, especially in a hot climate. And we typically organize a series of webinars that could happen bi-monthly, and where we invite our working group members and other experts in this field and ask them to present their insight on passive cooling, followed it by member discussion and Q&A. And so please ensure that this meeting will be recorded and upload it to a working group website after the meeting for the knowledge sharing purpose. And also, if you don't mind, please introduce yourself in the chat. Maybe feel free to mention your name, organization, and where you come from today, like a location, and so that other members can understand where you are from and what types of sectors do you belong to. And also in relation to today's topic, which is the cool surface, if you have any relevant resources like knowledge product such as publication research paper, guidelines, case studies, or like some events you are planning, please feel free to share in the chat. So this is basically, you can use the chat as you like to communicate with other participants, and also the chance to showcase your work as well. And yes, and also if you have any questions during the presentation, feel free to write in the chat, and so that we will address that in the Q&A session afterwards. And our essential goal of this working group for this year is to enhance knowledge base on passive cooling, which could feed into our upcoming global passive cooling guidelines and online database for case studies for the COP30. So thank you very much for those who have already reviewed our first draft of the table of contents for these guidelines. We are currently absorbing all the comments and try to reflect those in our draft. So, and we are hoping to have a second round of the review shortly to strengthen these guidelines. And okay, so without further ado, I'd like to start today's webinars. And today, one of our working group co-chairs, Rajan Rawal from the SEPT University, India, will moderate the session. So without further ado, let me give a floor to Rajan to explain a little bit about today's webinars and also introduce the distinguished speakers. So over to Rajan, please.
Thank you. Thanks, Ganai. I'm Rajan Rawal, part of the SEPT University based out of Ahmedabad. I'm one of the working group chairperson. There are three working group chairperson is working with the UNEP on this particular activity. Myself, Hub Leisure, and Professor Lorenzo from Polytechnic Milano. And we rotate ourselves to moderate various webinars. Today, it's my privilege to introduce Sarah Schneider, who will be delivering the webinar. Sarah is Deputy Director of Cool Roof Rating Council, which is based out of US. It's a non-profit organization and in the business of working on scientific knowledge creation, and also implementation of cool surfaces. Uh, Sarah also looks after the code and standards and also part of the advocacy group at the Cool Roof Rating Council. She will be talking about importance and also some of the nitty-gritties and technicalities of cool surfaces and cool roof. We will have about 40 minutes of delivery from Shara, and then, as can I say that if you have a question, please type it down on the chat box. I will moderate that. And if you're available at that point in time, I also will request you to unmute yourself and ask a question to Shara. So before not wasting time too much, let me hand it over to Shara. Shara, over to you. Thank you.
Thank you. Well, let me go ahead and share my screen. We rehearsed this before you all joined, but I'm not good with technology, so I might mess this up again. Can I get confirmation? You can see my screen, the full slide? Okay, awesome. All right. Well, I'm sorry.
Now it's not. Yeah, now
okay.
it's comes back. I think it's an animation or.
Can you see it now?
Yes, we can see that. Okay, no problem.
Okay.
We can see that now. Yeah.
I was shuffling through all my various windows and screens that are open. So, okay, well, thank you so much for inviting me to present today, and thank you for the introduction, Rajan. So, as mentioned, I'm going to talk about the use of solar reflective cool surfaces as passive cooling strategies, specifically in the context of the building envelope. But before I begin on that, I do want to provide some additional background about the Cool Roof Rating Council, or CRRC for short. As Rajan said, we are a nonprofit organization based in the US, and our mission is to bring objective scientific information related to cool surfaces to the critical discussions and informed decisions about the impacts of heat islands, extreme heat, and energy use in the built environment. And we achieve our mission through 3 different types of activities. First, we provide third-party product ratings for the energy and heat-related radiative properties of roofing and exterior wall materials through product rating programs. I'll talk more about these programs and about radiative properties later on in the presentation. Those product ratings are primarily used for compliance and enforcement of building energy codes, urban heat island ordinances, and also any programs that promote the installation of or provide some type of financial incentive for the use of cool surface materials. Secondly, the CRC conducts technical research in collaboration with industry, academia, and government to support the science behind our product rating programs. And thirdly, we conduct education and outreach to help a broad range of stakeholders understand what cool surfaces are and how they can be used to boost heat resilience and conserve energy in our communities. So we were established as a nonprofit back in 1998 through a collaboration between the roofing industry, government, energy utilities, and lots of other stakeholders. We were created in response to a regulatory agency in California, the Energy Commission, for their desire for a third-party organization to verify the data that would be used for cool roof code compliance. Because at that time, they were considering incorporating cool roof provisions into the statewide building energy code, which they did. And then fast forward 20 years, and the CRC expanded the scope of our organization beyond just roofing materials to also include exterior wall materials. And we've had a wall product rating program in operation since 2022. And then more recently in 2024, we expanded our scope once again to include pavement materials. And we're currently exploring the potential development of a pavement rating program. So I'm going to just talk a little bit about what we're doing currently with pavements, but my presentation is really going to focus on roofing and wall materials, or the building envelopes. So the primary goals of the CRRC for creating a pavement rating program are to provide science-backed education on the effectiveness of cool pavements in combating extreme heat and the urban heat island effect, and to create a free public directory of pavement material ratings to support municipalities and other end users in creating cool pavement requirements or incentive programs. Here in the US, there has been a lot of momentum around around cool pavement pilots at the municipal level across the country. There is no standardized system for measuring the radiative properties or communicating those properties to the public. So that's where the CRC comes into play. So since we officially expanded the scope to include pavement materials, we have convened a large group of stakeholders representing industry and end users for a pavement steering committee whose objective is to create a plan for a rating program. This involves assessing the appropriate testing and aging protocols of pavement materials, the necessary labeling requirements to support code compliance and enforcement at the local level, and then of course a financial model for the program. The committee is also discussing the appropriate metrics, which would include the surface radiative properties, solar reflectance and thermal emittance, which I'll talk about in a moment, but also potentially thermal comfort metrics. So in interviews with stakeholders across the US, thermal comfort is a topic, I should say, a hot topic, no pun intended, that is often brought up. People want to know, what does this mean in terms of the impact on people? And so our steering committee is also discussing whether or not we want to move beyond just surface radiative properties to also consider thermal comfort metrics. Now, settling on a specific metric is where we're currently in discussion, since there are so many different ways that thermal comfort is measured. The committee is also exploring an appropriate protocol for aged ratings of pavement materials. I'll talk about what aged ratings mean later on in the presentation in the context of building envelope materials. But as you can imagine, the durability and weathering of pavement is a lot different than walls and roofs. There's a lot more use cases. Obviously, people are walking on pavement, driving on pavement, and so forth. So this is another key technical topic under discussion by our committee. Okay, so now that I provided a high-level overview of the CRC and what we're currently working on, I will go on to describe the co-benefits of cool surface materials. So again, focusing on roofs and walls, and how these materials are evaluated for their radiative performance. So I do want to acknowledge, to the passive cooling working group, that it's absolutely necessary to employ a wide range of solutions to tackle the problems of urban warming, including the use of passive cooling strategies like vegetation, shade trees, shade structures, and water features. But again, I'm really just going to focus on a couple of interventions, and those are solar reflective roofing materials and solar reflective wall materials in this presentation. Now, the use of cool surfaces provides benefits at multiple scales, so the impacts are more significant for buildings with little to no insulation or mechanical cooling, and also for buildings in heat vulnerable communities, which by and large are typically low income or impoverished communities. At the individual level, cool surfaces reduce indoor temperatures, which helps improve comfort and safety during hot weather, helps improve learning in schools because children are not overheating in classrooms, and helps increase worker productivity in offices and factories. At the building level, cool surfaces reduce solar heat gain, and in turn the demand for mechanical cooling, and then of course the associated costs of running ACs, air conditioning. And at the community level, cool surfaces raise local albedo, which helps lower outdoor air temperatures, especially at night. Cool surfaces also help improve air quality by slowing the formation of ground level ozone, and also help improve grid stability during hot weather by reducing peak demand. And then at the global level, cool surfaces help reduce greenhouse gas emissions through a reduction in energy use and also contribute to atmospheric cooling by increasing the Earth's albedo. So the illustration on screen describes the flow of radiant energy as heat between the sun, the building surface, building interior, and the building's surroundings. The metrics that determine the coolness of a surface material are solar reflectance and thermal emittance. Solar reflectance, also known as albedo, is the fraction of solar radiation that is reflected by a surface. It is measured from on a scale of 0 to 1, where 1 is the most reflective. And then with thermal emittance, the other property, it is the relative ability of the surface to re-radiate any heat that was absorbed. So like reflectance, the higher the thermal emittance value, the more emissive the material. Now, I do want to take a moment to explain solar reflectance index, or SRI. This is a super common metric associated with cool roofs. It is a calculated value that combines the measured reflectance and measured emittance values of a horizontal surface into one index value. SRI values are typically between 0 and 100, but can exceed 100 for extremely cool materials, and then conversely can actually go negative for extremely absorptive materials. I do want to call out that SRI is not an appropriate metric for vertical surfaces. It should not be used for walls. It really is designed for roofs. It is used for some pavement materials. We're actually exploring the appropriateness for that. But the test method that was created for the calculation to achieve SRI was really designed for rooftops, horizontal surfaces. Okay, so in terms of cool materials, the coolest that are available on the market today are those that are white or light in color. And this is true no matter where you are in the world. And this is, of course, because white is naturally reflective. However, not all cool products are white or light in color. Innovations in the industry, specifically here in the US, I really can't speak to industries outside of the US, my apologies. But here in the US, the market for cool surface materials has grown immensely over the last few decades. And during that growth period, technology has been invented to enable darker colors, so visibly darker colors, to actually have higher solar reflectance. We call these cool color or spectrally selective products, and they are engineered with special pigments that are really efficient at reflecting near infrared radiation. So on screen are some examples. So the top row shows those cool colors. So these are paints that have been formulated with those IR reflective pigments. So those again are on the top row. And then on the bottom row are their conventional counterparts. So these are paints that have conventional pigments, not the IR reflective pigments. So if we look all the way to the left-hand side of the screen, the reflective black on the top, the cool black, I should say, reflects 41% of incoming sunlight. So that's a reflectance of 0.41. So translates to 41% of sunlight, whereas its counterpart, the conventional black below it, only reflects 4% of incoming sunlight or solar radiation. So here in the US, and potentially elsewhere outside the US, the products that use infrared reflective pigments are typically asphaltic shingles. We call them cool shingles or reflective shingles, as well as reflective asphaltic membranes. So those have been engineered with reflective granules. So those are granules that have been coated with the IR reflective pigments. There's also factory coated metal and wall panels. That industry adopted IR reflective pigments many years ago. And then there's also roofing tiles that are glazed with IR reflective pigments as well. And then there are architectural coatings, so exterior wall paints available on the market that also are formulated with those. So I do want to note that these types of products that use these special pigments will usually be marketed as such, so that it's very clear to the consumer that they are different. They provide a different benefit, and also can help explain the potential cost differential. Typically, these products do come at a slight cost premium, at least here in the US. In recent years, there's also been the development of passive daytime radiative cooling, or PDRC materials. I'm sure many of you are familiar with that. There's been a lot of hubbub in the news about super white paints and other types of PDRC materials being developed by researchers at various academic institutions. So PDRC materials are highly reflective and highly emissive, which means they emit more heat than they absorb by taking advantage of long wave infrared thermal radiation. PDRC materials are able to radiate heat even under direct sunlight and can reduce surface temperature to below ambient outdoor temperatures. So I do want to note that this is still a burgeoning industry and that products are not widely available in the market. There are companies that are moving beyond startup and trying to really make it more commercially available, but it's still not there yet. But I think it's just a matter of time. So I do want to take a moment to highlight some of the key considerations when it comes to the appropriate use of cool surface materials in order to maximize their benefits and also keep costs down for the building owner. Unless specified by the manufacturer, coatings formulated for walls are not intended for use on roofs. A wall paint may not be as durable or effective if applied to a roof, and therefore would likely need to be repainted over and over and over again. And then it might also be introducing unintended consequences. You know, one of the things is that roof coatings are thicker than wall paint. They're intended to not only help reflect incoming solar radiation when they're white or light in color, but they also have waterproofing properties, which wall paint does not. Wall paints typically, serve an aesthetic purpose. When it's all said and done, it's just best to follow the manufacturer's instructions when applying any type of coating to any type of building surface, just to be safe. So as mentioned earlier, the CRC publishes radiative property ratings for roofing and exterior wall products. And to obtain these ratings, products must go through radiative property testing. The test data serve as the ratings. So the ratings are based on initial and 3-year aged reflectance and emittance measurements. And the CRC's role in that is to administer the programs, enforce the requirements, and then also to verify that the data are accurate. This means that the appropriate test methods and procedures were followed for the particular type of roofing or wall material, and other types of data reporting requirements. Once a product ratings are verified for accuracy and approved, we then publish them in online directories, which are accessible on our website. I'm going to talk about those directories a little bit later as well. So the manufacturers of these products are the ones that need to facilitate the process. So they come to the CRC for the ratings. They can also use the CRC product label once their product ratings are approved. And they might want to do this for consumer education or marketing, or when it's required by a jurisdiction for code compliance. For example, the state of California requires CRC ratings, and products that are installed for compliance across the state need to have a CRC product label on the actual packaging of the roofing product. There are other jurisdictions across the US that also require the label. This just helps the local building department who's responsible for enforcing the code, helps them as a job aid, so it's a lot easier for them to check compliance. So on screen are some of the measurement devices that are used in surface radiative property testing. Excuse me. Now, the type of material, so the type of roofing or wall material and the associated industry standard test methods determine which device to use most of the time. For the CRC's product rating programs, the devices on the top row are the most commonly used for product testing. These are a portable reflectometer, portable emisometer. Excuse me. We do allow products to be tested in accordance with the standard test methods that are written for the devices on the bottom. They're just not as commonly used here in the US, particularly the pyronometer on the left-hand side, because those are meant for, excuse me, one second. I have a frog in my throat. Sorry, it's a weird American expression. Excuse me. Okay, so the pyronometer on the left-hand side, that's intended for taking outdoor solar reflectance measurements, but the conditions need to be just right in terms of the amount of sun in the sky, the angle of the sun, and so forth. So it's not a practical measurement device for laboratory testing.
Shara, do you want to take
Yes,
30 minute,
let me go
30
ahead and-
second,
Yeah.
30-second break? Yeah, it's okay. You
Just
can keep
one
on.
moment. My apologies. Sir.
No worries, no worries.
Okay, I'm back. Sorry about that. It's allergy. Okay. So moving on. No, I mentioned earlier that we do initial and aged ratings. So initial just basically means that products are tested when they're new. Aged means something different. So the reason aging is required by the CRC and many energy codes is because the natural weathering process helps us understand how a product's radiative properties will change over time due to atmospheric soiling, ultraviolet light exposure, biological growth, and other environmental conditions. So here in the US for the CRC product rating programs, also required in pretty much all of the energy codes that have cool roof provisions, that weathering, so this is field exposure where samples are exposed to weather for 3 years undisturbed. So we have test farms in a hot and arid climate and a cool and temperate climate and a hot and humid climate. So again, samples sit out there at an appropriate slope and tilt, undisturbed for 3 years. Once they complete 3 years of weathering, they are removed from the test farms and sent back to a test lab for aged testing. So these samples are not cleaned. And so these soil samples are what the measurements are based on. And so because they are in 3 different climate zones here in the US, we take the average of those reflectance and emittance test results and then publish those as the aged ratings. It gives us kind of the average US value for 3-year weathering. In addition to natural aging, the CRC also allows laboratory aging of roofing materials. These are interim aged values. We call them CRC rapid ratings, and it's an option for manufacturers that want to bring their products to market while the product is undergoing 3 years of natural weathering. So laboratory aging can be completed in under a week and is conducted in accordance with an industry test standard. I do want to say that at this time, there is no industry test standard for the laboratory aging of wall materials. So the CRC doesn't have wall rapid ratings available at this time. I'm not aware of any efforts in the industry to create a laboratory weathering protocol for wall materials. But I do want to say, if you think about it, a vertical surface is going to weather differently from a close to a horizontal surface or close to a flat surface. So the aging in the context of radiative performance of walls is actually a lot slower. There's less degradation compared to roofs. The other thing that I didn't mention that I just remembered now is that for the CRC project rating programs, we require testing to be done by independent test labs. So these are testing facilities that have no affiliation with industry. These test labs must meet a series of requirements by the CRC. Notably, they must be accredited to the international standard 17065. I do want to call out that we have our very first international approved testing facility for the CRC product rating programs, and that is Rajan's research center at CEP University. So we're very excited to have them part of our program and as a member of the organization as well. Okay, so I do want to take a moment to highlight some cool surface case studies. I am going to talk about a few cool projects here in the US, but I do want to briefly mention a cool roof project in India that the Cool Coalition was involved in. I'll read an excerpt of a news article published 2 days ago in NM Pro News magazine. I'm sorry to be reading the quote, but the Cool Roof Initiative implemented in Chennai's Perumbakkam has drawn international attention, with the United Nations Environment Program citing it as a replicable climate innovation for rapidly urbanizing regions. Recognized as a scalable urban heat mitigation model, the project is now being considered for similar rollouts in India's capital, Delhi, and other heat-prone cities. This intervention, developed in partnership between the Tamil Nadu government, the UNEP-led Cool Coalition, and the Rocky Mountain Institute, is part of a larger urban heat resilience framework. A pilot was launched at the Lighthouse Project in Perumbakkam, where cool roof technology using high solar reflective paint was applied to 2 residential blocks. The result was a tangible temperature drop of 5 to 8 degrees Celsius within homes during peak summer months, transforming thermal comfort in affordable housing sectors. So just kudos to the Cool Coalition and their partners on that. And it's exciting to hear a rollout. And 5 to 8 degrees Celsius reduction is, I think, quite significant. So this has got really important implications, obviously, for public health and energy use. The Cool Coalition also actually has features a lot of other cool roof and cool surface projects and case studies on the Cool Coalition website. So I encourage you to check those out if you wanted to learn more about what other regions are doing that are supported by the Cool Coalition. So I also want to call out some excellent resources that include some cool surface case studies. So one is the Primer for Cool Cities, which was published by the World Bank a few years ago. And then the other is the Practical Guide to Cool Roofs and Pavements, which was published by the former US-based NGO Global Cool Cities Alliance. Though these resources are several years old now, the information in them still provide really great examples of cool surface efforts that could be replicated elsewhere. Okay, so cool roofs in the US are pretty prolific, particularly for commercial buildings with low soak roofs located in climates where there are more cooling degree days than heating degree days. As such, case studies often include buildings where a cool roof and several other energy efficiency measures were installed. So in other words, it's kind of challenging to find cool roof case studies, current ones, just because cool roofs are pretty widely utilized, at least in the commercial and multifamily sectors here in the US. And so at this point, they're combining them with other energy efficiency measures, especially because we have federal funding available that homeowners and building owners want to take advantage of as much as possible to increase the energy efficiency of their homes. So the before I go into these case studies, the reason why I chose these as well is because they include some unique attributes that I really wanted to highlight today. So the first one is a project in Los Angeles where roofs on 3 single-family homes were replaced with new asphalt shingle roofs. So it was the existing roof was an asphalt shingle roof replaced with a new asphalt shingle roof. And then they also installed rooftop solar PV. So these were projects done in 2023. What makes those projects unique are one, the new asphalt shingle roofs that they installed contain that IR reflective pigments to help reflect solar radiation, but also those granules were coated in nitrogen oxide. The shingles, I'm sorry, were engineered with nitrogen oxide abating granules. So in other words, the roof was able to work triple duty to keep the home dry during rain events, reduce solar heat gain, and also eat smog in a city well known for its poor air quality. This project was also a partnership between a local NGO, a national solar installer, and roof product manufacturer, and was funded by the local municipal utility through an emissions reduction grant program. So I'm going to talk a little bit more about the importance of public-private partnerships when I talk about how to support wide-scale deployment of cool surfaces. But I also want to talk about wanted to mention that this project was funded through an emissions reductions grant program. So going back to the multiple co-benefits of cool roofs in this context, making that connection clearly that the cool roof is going to reduce solar heat gain, which if it's an air-conditioned building, reduce the cooling demand, therefore the energy use of that building, therefore a reduction in greenhouse gas emissions for not generating the use of the energy that otherwise would cool that building, while also helping to reduce ground level ozone, which is a key ingredient in smog. So making that connection between that and the outcome in order to successfully be granted funding for something that might not be very clearly understood or thought of in the first place. So that is another attribute of this project that makes it quite unique. The other case study I want to briefly highlight is a cool roof coating that was applied to the country's largest wholesale produce market. This was a project in New York City, specifically in, I think it was the borough of New York City's Bronx borough. And it was done in 2021. It was administered through the NYC Cool Roofs program, which is a municipal program in the mayor's office for the city of New York. And it was done in collaboration with the HOPE program. The HOPE program is an NGO that provides training and long-term career support for New York residents who are working to overcome systemic and other barriers in the workforce. So this is a really amazing program that brings in workforce development, environmental justice, energy efficiency, and urban heat mitigation for residents at no cost to the building owners. The program has been around since I would say about 15 years now. The funding for this particular cool roof project what came from a federal grant. So again, this project was done in 2021, very different time. I certainly hope that this program continues to be able to get federal funding to do this really amazing work that they're doing throughout the city of New York. And then finally, I want to mention a couple cool wall murals, which highlight the intersection between education and art while providing passive cooling benefits. The cool wall mural on the left was a project at a primary school in partnership with a community-based organization. And then the cool wall mural on the right was a project of a university, UCLA in this case, the Luskin Center at UCLA. And both of these murals use solar reflective paints, and the intent was to convey the benefits and creativity of cool walls while providing something aesthetically pleasing to look at. So cool walls are actually it's starting out to be kind of a trend here in the US, potentially elsewhere. I look forward to seeing more and more instances of cool walls using solar reflective paints in the future. Okay, so there are several factors that affect wide-scale adoption and deployment of cool surfaces, and which I will describe over the next few minutes. So based on primary and secondary research that I've conducted, there are 4 primary challenges that we contend with here in the US, and I reckon these are also experienced around the globe. The first is a lack of awareness and education about cool surfaces. Not just their existence, but also their benefits, the lack of product availability and product affordability, lack of financial support to help subsidize the cost of materials, particularly for those experiencing poverty, and then also the potential unintended consequences of improper design or installation of cool surface materials and the misunderstanding or misinformation that is spread as a result. I potentially think of cases, anecdotal cases where people have concerns about moisture or condensation from basically replacing a dark roof with a reflective roof. This is condensation and moisture are issues with any type of roofing assembly. So it really comes down to the proper and appropriate design and installation of those materials. Okay, so what we know is that ratings, research, and education are critical to supporting the wide-scale adoption and deployment of cool surfaces. So again, this is where what the CRC's mission, what we're trying to do is raise awareness, do the research to support the ratings that we publish, and then just continuing to provide as much data and information through resources, which I'll talk about here in a couple of minutes. The other thing that I alluded to earlier is industry support and collaboration between private and public sectors. These partnerships are particularly important for raising awareness and educating the public, also for obtaining quantitative and qualitative data, because these are oftentimes pilot projects, and then that data will go on to hopefully support policies and programs for cool surfaces. And then also for getting stakeholder buy-in and successful implementation of more cool surface installations in the future. In addition, the adoption of cool surface policies, so those are notably in building construction codes or green building standards, are also key in supporting wide-scale deployment of cool surfaces, especially if the requirements are mandatory. However, policies without teeth may not be effective market drivers for wide-scale deployment and could result in poor performing products flooding the market. And this is where third-party product ratings, excuse me, play a really important role. For consumers, the ratings shed light on the radiative performance of roofing and exterior wall materials. The ratings enable consumers to identify products in the marketplace that comply with building codes that may qualify for financial incentives or are eligible for green building certifications. And the fact that the ratings are verified by a third party also provides the assurance that the data are credible and accurate and have been obtained in accordance with the appropriate test methods and standards. This is why third-party product ratings are widely used by state and local government agencies and energy utilities here in the US, and the development, compliance, and enforcement of policies and programs that promote their use. So currently, the CRC is the only organization in the world that publishes the radiative property ratings of roofing and exterior wall materials. Hopefully, there'll be more organizations like the CRC established in other countries. For now, anyone can access the CRC directories, and there are products on the directories that are actually sold outside of the US, so specifically in like South Korea, in Mexico, in the United Arab Emirates. and it's likely because there aren't any other rating systems out there at this time. So, but these directories are designed for optimizing the search for products to support code compliance and enforcement, to again qualify for financial incentives. The databases are also used for research studies. You can actually export the directories to a CSV or Excel spreadsheet and do more rigorous filtering or sorting in order to get an understanding of the range of reflectances for various roofing and wall products on the market. I do want to note that CRC ratings are not the same thing as certifications. So any roofing or wall material can be rated, and their ratings can be on the directory. And the reason we do this is that we are an objective third party. We are not, we don't set a performance threshold. There's no pass or fail. It's you meet all the requirements for testing, the data are accurate, the ratings will go online. So the directories do include a wide range in SRI and SR for both roofs and walls. It's the jurisdictions or the programs that set those performance thresholds. So they rely on the data here to understand what do we have in the market, what's a sensible threshold or baseline for a policy. And then I just will conclude my presentation by highlighting some of the informational resources we have on the CRC website. These are all free and should be accessible by anyone with a computer. So in addition to the product directories, we have a list of cool surface code standards and programs around the US and Canada, as well as a list of available cool surface financial incentives on our website, coolroofs.org. Since I'm speaking to a global audience, I want to note that the various codes and programs on these lists likely don't, affect you in any way, but could be helpful in terms of kind of seeing, what are others doing, jurisdictions or utilities doing. These could be models to replicate elsewhere. Additionally, there are also a lot of fact sheets and educational documents on the website that cover a range of cool surface topics. These resources are tailored to different audiences, but at this time, they're mainly available in only English. They're downloadable PDFs. I think you could probably use some kind of AI program to translate them. But I do want to note that the CRC's International Committee is currently discussing the potential to translate CRC materials into other languages if there is interest. We also have a lesson plan on the website for middle school educators interested in teaching their students about the urban heat island effect and the role of cool surfaces. This lesson plan is free to access and includes 3 short animated videos, a teacher guide, and instructions for a student-led experiment, among other resources. I think, will these slides be circulated afterwards so folks can?
Sure. Yes.
Okay, great. So yeah, the URL and the QR code to access these resources will be available after the webinar. Finally, if you're interested in a deeper dive into cool surfaces, the CRC does have a free on-demand continuing education course. It's hosted through a third party called AEC Daily. It is a self-paced course and includes a short quiz if you're registered for with AIA or so the American AIA, the U.S. Green Building Council, or the International Institute for Building Enclosure Consultants, as well as a lot of other associations. If you wanted to get continuing education credit, but anybody can take this free course. You don't need to be registered to do that. The last thing I want to mention is the CRC is available as a technical resource to organizations interested in establishing a rating system in their respective countries. Specifically, we're able to provide deep knowledge and guidance around organizational structure and governance, technical assistance with the development of testing standards and rating protocols for different climates, and hands-on laboratory training for organizations interested in learning how to conduct rated or property testing. And with that, if you are interested in learning more about the technical assistance that the CRC can provide or anything else that I've talked about, you can email me on screen. We can also, I'll pass it over to Rajan to moderate the Q&A. And hopefully I've stopped sharing. Did I stop sharing?
Yeah, or you can keep the main title slide up.
Okay.
The first one.
Okay.
Great. While you do that, and I'm scrolling through the comments, there's a lot of discussion on insulation and cool roof together, but I'll put that at a lesser priority because Kurt has already given a lot of inputs on that. But let me start with there are a couple of resources Andreas has shared from the Global Cool Cities Alliance. I request participants to look at that. There's one question is on interested in persistence of these lab values for a reflectance over time when exposed to the real world conditions. So I think this is from Andreas and is asking about the aging property if you want to revisit that part. But the question, if I read here, is that I would be interested in the persistence of these lab values for reflectance over time when exposed to the real world conditions. I would expect environmental dirt, which will start covering the reflective material, deteriorate the values. Is there any empirical evidence for this phenomena?
Yeah, no, it's a great question. Yes, there's data. So earlier in the life of the CRC, we have a technical committee of experts, and we work closely with test farms and Lawrence Berkeley National Laboratory and Oak Ridge National Laboratory to look into this question. What is an appropriate amount of time for materials to be sitting out for in the field for exposure to weather and pollution, et cetera. So based on the data, 3 years was determined to be the point at which degradation of radiative properties starts to slow down for most materials. And I think it was possibly between 7 and 8 different types of roofing materials, roofing product types. So we're talking tile, metal, coatings, asphaltic roofing products, and others. So again, 3 years was determined. We actually we've done a study, sorry, it's been so many years. I don't remember where we're at, if there was an additional phase planned, but we have revisited the data over the years to get a sense comparing with the data that we have now. And I believe that 3 years is still determined to be the appropriate time frame. Of course, local conditions are going to change that, right? So if you live in a city where there's a lot of pollution, you're likely going to see radiative performance go down more quickly with for example, a very white surface. There are manufacturers that do recommend getting on top of the roof and cleaning the roof. Whether or not that is a practical, thing to do, it's up to the building owner or building manager. So again, yeah, it's very specific to local conditions. So again, in terms of the CRC, the data that we have and have analyzed, it's obviously going to have to be an average, and so the 3 years is the point at which made sense from the scientific standpoint. Hopefully that answers your question. Oh, I can't hear you, Rajan.
Sorry, I was on mute. Do we have N online? There are a couple of questions from N. I think if I repeat one is on the VOC content. So the question here is that cool color coatings, how long are the reflective pigments effective? So partially you have given the answer, but you would like to give answer specific to the color, cool color coatings. The same question asks for how sustainable are there? Are there any VOC in these coatings? This is refers to the cool colors, and the same
Yeah.
person has and the same person has asked, is there any ISO standards for testing?
Okay. Yeah. Unfortunately, I don't know. Looking at VOCs is beyond the scope of the CRRC. There are jurisdictions in the U.S. that are very strict about VOCs and other ingredients, I guess, or impacts of paints and coatings. But I wouldn't know. Cool color coatings for metal products are quite sustainable. I shouldn't sustainable. The radiative performance is quite durable. These are basically coil coated metal substrates. So they are factory coated and quite durable in the field. I can't speak to degradation of reflective pigments in the other types of roofing materials. Asphalt shingles typically have the shorter lifespan compared to other roofing materials. They're also more prone to biological growth like moss or algae, which all obviously impact radiative performance, though there are some products that are formulated to prevent moss and algae and other type of biological growth. So unfortunately, I can't really answer that question very, very well. Sorry about that. In terms of ISO standards for testing, the CRC requires any independent laboratory that wants to participate in our program, so be a laboratory that's eligible to do the testing of their products, needs to be accredited to ISO 17025. So this is specifically for laboratories doing product testing. I don't know if that answers your question, Anne. The test methods are not ISO standards. They're ASTM standards as well as CRC standards. I'm not aware of ISO standards for product testing. They may exist. They're just not what we require for CRC ratings.
Mm-hmm. Okay.
Thanks. So that then there are a couple of questions related to the value of insulation, and if you have a presence of insulation in a heavy mass building or a lighter building or lighter structure, how effective the cool roof is going to be. But I think there are a lot of discussion on that, and Kurt has provided a good amount of support by referring to some literature, and he has shared that. But if I concise all that discussion into a couple of lines, and if Sarah, you want to address that, if you can just talk about the trade-off between a thermal insulation on the rooftop, whether it's under deck or over deck, and a presence of a cool roof paint.
Well,
yeah, thanks. Go ahead.
Yeah, I can't speak to insulation above or below roof deck in terms of what that means for solar heat gain. But ultimately, insulation and reflective roofing can be mutually beneficial for each other. I think though, in the context of urban heat island mitigation, that's, when you have an area that has a lot of reflective surfaces, so a lot of cool roofs, potentially cool pavements, cool walls, you're going to raise the albedo of that community, that area, which in turn is going to help lower outdoor air temperatures. And so I think that, specifically in buildings that are not conditioned, insulation is going to be helpful to a certain degree, but once that insulation just slows the transfer of solar radiation as heat. Once it gets in the building, it's going to be trapped in the building, especially if the building is not ventilated properly. So if you have a surface that's going to slow solar heat gain, regardless of the amount of insulation in there, it's going to be a benefit to occupants in that building, whether or not it's conditioned or air conditioned, especially in a power outage during a heat wave. I hope that answers your question.
Yeah. Can cool roof work in negatively in the winter time? So basically, when heating is required, do they help or do they not? Yeah.
It depends. It depends. So there is a thing called the winter heating penalty, which means that your heating bills might go up in the winter if you have a very reflective surface on your roof. However, it depends on the climate. So there has been a lot of research into this topic, and the findings basically are that unless you're in a very northern climate, factors like the angle of the sun, so where the sun is in the sky during the winter months, is lower. There's more atmosphere for the solar radiation to travel through, so there's a lot more particulate matter and so forth for that sunlight to reach that roof surface. There's sometimes there's snow on the building, so the color of the roof does not matter. The amount of daylight is also shorter. You know, the sun is out for a short amount of time. And then also, speaking of sun, in a lot of colder climates, it may be overcast. So the amount of solar radiation is less intense. So again, unless it's in a very specifically cold northern climate, a cool roof may be, if the building is air conditioned and air conditioning is needed, the winter heating penalty may be quite negligible compared to the cooling energy savings in the summer. So it is very specific, but may be overblown in certain cases.
Thanks. I don't see any other question. Let me refer it to Ganai if he can spot any specific question other than the discussions which we had on the chat. If not, over to Ganai.
Yeah, thank you, Rajan and Sarah. Maybe finally, if you want to speak like orally, please feel free to do so. Like maybe someone want to speak rather than texting in the chat. So, and also it could be a little bit more interactive. So I don't know if anyone want to speak. Please, yeah. Yes, Sunita, please, from India.
Yeah. So, yeah. Hi, Sarah. Thanks for the wonderful presentation and sharing of so many resources. One thing that we observe is that the deterioration of the paint with the dust and the reapplication. And hence there is a lot of resistance to the application of cooling paints. Is there something that could stay on for a long time and resist the deterioration due to dust?
Yeah, I'm not aware of any particular products, and I also, if I did, I'm not permitted to say. We need to be very careful about not promoting one particular product or company over another. So, but with that said, I am not aware of any particular product that is going to avoid accumulation of dust and therefore bring down the radiative performance a little bit. My apologies.
Yeah, probably as an academic, I can practice some more freedom here. Will definitely not provide a direct answer, but the cool roof property can come from three kind of products. One is paint, one is membrane-based paints, and one is tile. And all these three will have a different kind of aging property. And if you pick up the aging property, which is little less, then probably you will be able to prolong the performance for a longer period of time. So just look at these three, and Sunita, probably I can connect you with you on the phone separately. Thanks.
Yeah. That will be really useful, Rajan. I'll connect with you. Thank you. I mean, my worry is, the resistance that I see, and how do we overcome that resistance? Yes. Thank you.
Thank you, Sunita, for the important questions. Yeah. And are there anyone else who want to speak?
No.
If not, yeah, we are closing. Okay, so thank you very much for the fantastic presentation from Sarah, and also great moderation from Rajan. And I really appreciate both of you, and also all the participants from across the world, regardless of the time difference. So we will definitely share the presentations and all the materials introduced during the webinar, and as well as all the links in the chat from our members. So you can still learn a lot after the webinars. And if you are interested in know more about any specific issues, please feel free to reach out to us so that we can connect the appropriate experts. And also for this passive cooling working group, so for this year, our ultimate goal is to produce the passive cooling guidelines toward COP30, and where we relying a lot on your expertise from a working group. So we already did the review one time 2 months ago, and we are currently observing your feedback to try to reflect the comments into our guidelines. And also we are currently developing the full draft. So at some point, we want to ask you again to review that so that your insights can be incorporated as well as we acknowledge your names and the organization in the publication in the end. So, okay, maybe before we close, Rajan, you raise a hand.
No, yes, I just wanted to request if we know the date and subject for the next webinar, it will be nice for us to know. If we know.
Okay, thank you very much, Rajan. So for the next webinar, unfortunately, I cannot give the exact date and time, but we are planning it maybe next month or in September. So depending on our availability from the working group, like UNEP and co-chairs side. But we will definitely inform you of the upcoming webinars once it's ready. And also we are basically asking our working group members if you want to present anything under this working group, please feel free to reach out to us. Please send us your expression of interest so that we can try to accommodate you at some point this year or maybe next year. But that's all. Thank you very much, everyone. If we don't have any more comments, we are closing for today. So thank you very much again, Sarah and Rajan, all the participants, and have a nice rest of the day.
Thanks, everybody. It was a pleasure
Thank you.
presenting to you. Thank you. Take care.
Thank you. Bye.
Thank you.